Good morning. Today I would like to propose a network for the PdPR in the rural area. First, we see the proposal requirement, which include internet speed, internet stability, internet latency, sufficient bandwidth, and unlimited data usage. For the internet speed, video is very important in PdPR, which is whether it's a live or streaming of videos. So the recommended video type will be full HD videos, which run on the resolution of 1080 at 30 frames per second, which needs a minimum download and upload speed of 3 megabit per second. Internet stability. The online learning process must be a smooth process without any disconnection of networks. For the internet latency, online video streaming and live videos should have a low internet latency. This is important so that communication between the teachers and the students are smooth in the teaching and learning process. Besides that, sufficient bandwidth is very important too. Video conferencing at resolution 1080 with a 30 frame per second on a codec H.264, which this one is the most used for video conferencing, and a standard audio quality. The minimum requirement bandwidth is 3 megabit per second. So the estimated requirement bandwidth needed for the 20 household, which times by the minimum requirement bandwidth of 3, which require a 60 megabit per second of bandwidth. Besides that, unlimited data usage is very important too, because video consume a huge uh, amount of data. So it is important to have an internet subscription that come with an unlimited data usage. So we look into the challenges. Among the challenges, there are three here: distance from the nearest exchange point, cost consideration, and inconsistency connectivity. So distance from the nearest exchange point will be around 30 kilometers away from the village itself. There are only limited numbers of internet access technology that can be implemented because as data travels along the infrastructure, the signal become weak, which is called the signal attenuation. Cost consideration is another factor to be considered of because of the relatively very far away from the exchange point. We calculate the minimum distance, which is 30 kilometer, which is calculated from the straight line from the village and the exchange point. So rerouting of cable might take longer than 30 km to avoid obstacles like rivers and lakes. Cost of laying such as infrastructure would be expensive and is not cost effective. In return, service providers are not need to lay the infrastructure because they cannot profit from the low subscription of from the end user. Okay. In the village itself, they have a connectivity of 2G and 4G, but the minimum requirement for the internet speed is 3 megapixel to support the video. So on 2G, you can see that the average speed is 130 kilobyte per second until 200 kilobyte per second only, which is unable to support video streaming. So meanwhile for the 4G is 50 megabit per second until 20 megabit per second, which is sufficient to support the video streaming, but there is another problem to it, which is the weak signal lead to the attenuation. Okay, so the proposed technology to be used to cater all these requirements and challenges is using the satellite broadband system technology. In Malaysia, we have Starlink and Connect Me Now. So in this case, we will be using the Starlink. Okay, as you can see here, Starlink actually provides internet access to whole Malaysia. You can see from the colored map here. It shows that the whole Malaysia, uh, the availability of the network in whole Malaysia. So you can see here the download speed for a residential use plan. The download speed is 25 to 100 megabit per second with the latency of 25 to 60 millisecond, which is good enough to cater this PdPR. Okay, for the hardware, what Starlink kits provide, they'll provide you the router, the antenna, which is the Starlink, and the base, and the connection to the antenna itself, the Starlink cable, and the AC cable. This whole thing will cost 2,300 for the hardware. So for the ground research, we researched that the house and we map it into the diagram. So the whole village is within the 300-meter radius, and the 20 houses are scattered around in this 300-meter radius. So the square here, it represents the house. The red circle here, it represents the Starlink internet access point. So we need 4 Starlink internet access point here, with each one located in the middle of the quarter to reduce the distance between the internet access point and the house. So you can see here that the maximum length from the internet access point to the house will be 75 meters only, which is sufficient to cater the cable distance. So this is the picture of the ground pole mount for the Starlink antenna. So the Starlink antenna will be located in the middle of the quarter, so it will be an open space. So this is how it works. So the Starlink antenna located at the center of each quarter, with the radius of the village itself is 300 meters. So we connect to the router, to the Starlink router, which is provided in the Starlink setup kit. So what we need to get from external shop is that we need a switch, a TP-Link at port switch, so that it can connect all the cables together to all the house. So maximum uh, length cable that we use is 100 meters only. We are using the Cat5 Ethernet cable, the Belden E Cat5 Ethernet cable. So the maximum length from the switch to the PC will be 100 meters only. This is the whole picture of the deployment of the local network. So the most important here is the cost of the setup. For the Starlink setup, the Starlink hardware setup itself, it costs 2,300. So we need 4 Starlink internet access points. So we times it by 4, you get 9,200 for the cost of the hardware itself. Meanwhile, for the TP-Link at port switch, we need 4 because there are 4 access points. So the total will be 1,260. For the Belden Cat5 Ethernet cable, so one reel will cost 1,120.52 cents. So one reel is 305 meters. So the total household needs is 20 times 100 meters, which equivalents to 2,000 meter, which we needs 6 reels of Belden Cat5 Ethernet cable. When you times it by the one reel price, you get 6,723.12. So the monthly subscription for the internet plan will be 220 per month. This costing is excluded from the local network deployment cost. So the local network deployment cost in total will be 17,183.12. So each household need to pay is like 859.16. We compare it to other costs for fiber optic costs in 2021. For laying a fiber optic cable, the roughly estimated cost is 30,000 per km for rural area in Sarawak. So we calculate it for the minimum distance, 30 km will cost you around 900,000 to just to lay the fiber optic cable. Meanwhile, if to build a base station for 4G, which to improve the 4G signal, you can see that it involves a large cost here. US dollar 200,000. This is in US to build a macro cell so that it can cater of large areas of networks. So it will cost US dollar 200,000. So beside that, for the 4G, right, they need to pay permit in order to broadcast the 4G. So you can see that in Sarawak, for the first year, you need to pay like 37,600 just to pay for the permit itself only. And then second year, third year, fourth year, and fifth year, you need to pay 2,880. Meanwhile, for the 6 years, you need to pay 15,380, which total cost is more than 40,000, which is a high cost actually for the total of 6 years. Okay, we move to why we choose Starlink. This is because Starlink has a rapid deployment, wide area coverage, low cost, low latency, weather resilient, and internet speed. Okay, for the rapid deployment, you can see that cost, time, and labor depends a lot on geographical of the location to lay an infrastructure. For Starlink, we just need to install the software, the hardware itself to support the satellite broadband and is ready to transmit the data. So there's no point to lay an infrastructure between the local exchange to the end user. So beside that, Starlink have a wide area coverage. Satellite broadband uses satellite to send and receive data, and this technology is available even in the rural areas. So this satellite broadband has a very wide coverage if compared to other access technologies, internet access technologies. So the low cost of installation of Starlink satellite broadband is only cost 2,300 for each setup in the year 2023. So it's a simple setup if compared to other technologies because the setup only requires setup at the last mile only. Besides that, Starlink have a low latency. It works on a low Earth orbit satellite with the latency of 25 millisecond to 60 millisecond. Normally, satellite broadbands, the latency are very high because most of them works at the geostationary Earth orbit, which is the latency more than 500 millisecond. So Starlink has a weather resilient, with Starlink's broadband able to withstand harsh weather condition and it able to work during a heavy rains and it proved that it reliable in bad weather condition. Besides that, Starlink can provide download speed up to 25 megabyte per second until 100 megabyte per second for residential use, which is good enough for the PdPR. Okay, I think that's all for the presentation of the proposal. Thank you so much.